Numerical problems on superposition theorem. So find the value of current flowing through 8 ohms resistor and verify superposition theorem. So this is the given circuit. In this circuit we have to determine the current flowing through 8 ohms resistor. So let us assume current entering this resistor is some I amperes. So we have to determine this I value, that is the current that is flowing through 8 ohms resistor. Okay, so since they have asked us to verify superposition theorem, so if we have to implement superposition theorem or to verify superposition theorem in any given circuit, we must check the number of sources in the given circuit. So if you see here, there are two sources. One source of 4 volts, another source of 6 volts. So if more than one source is there in a given circuit, then we can implement superposition theorem in that given circuit to determine the unknown values. So since there are more than one source in this circuit, we can verify superposition theorem as well as we can determine the current flowing through 8 ohms resistor. So in the solution, let us consider step 1. In step 1, I am assuming that there is only one source acting in this circuit. So what did I do? I have removed this another source whose value was 6 volts by a short circuit. So this is our short circuit. I have replaced the voltage source of 6 volts by a short circuit. So voltage source has been short circuited. SC means short circuit. So now this is our given circuit, and our aim is what? Our aim here is to determine the current flow through 8 ohms. Let us assume the current in 8 ohms is some I dash amperes. Okay, so let us give some notation for the current that is flowing through 8 ohms when only one voltage source, that is only one voltage source, that is 4 volts voltage source is acting. The current flowing through 8 ohms is I dash. Now from the positive terminal of this voltage source, current will come out and it will flow through 5 ohms resistor. So current coming out of the source is I amperes. This is the total current that flows into the circuit. So this current, when I reaches this junction, okay, when this current I reaches this junction, what will happen? The current will divide into two parts. The current will divide into two parts. So the current that is flowing is 10 ohms resistor. We are assuming it as I1 current. This I1 current will flow through 10 ohms resistor. When it reaches here at this junction, again this I1 current will divide into two parts. Again this I1 current will divide into two parts. So it has two paths here. Okay, so one portion of the current will flow through 12 ohms, another portion will flow through 8 ohms. So current in 8 ohms, let us assume it is I dash. Now our aim is to determine I dash current. So first of all, let us determine the total current in the circuit. If I determine total current I can determine I1. If I am able to determine I1, I can determine I dash. Okay, so let us first of all determine current I. For that, we have to simplify this circuit. So if you observe here in this circuit, so if you observe here in this circuit, this is our circuit which I have copied in the another slide. the 12 ohms and 8 ohms, since current is dividing between these two resistors, okay, current at this junction will divide and some portion will flow through 8 ohms, some portion will flow through 12 ohms. Therefore, these two resistors are said to be connected in parallel. 12 ohms and 8 ohms, they are said to be connected in parallel. Okay. So, since they are connected in parallel, you can simplify this. So, what do you get? 12 is parallel to 8. So, equivalent resistance of these two elements which are connected in parallel is 12 into 8 by 12 plus 6. Sorry, what is it? 12 into 8 by 12 plus 8, not 6. 12 into 8 by 12 plus 8. You just simplify it, you will get 4.8. Okay. Now, instead of drawing this 12 ohms and 8 ohms, what you can do is, instead of drawing these two, now since you have determined the equivalent resistance of these parallel elements, okay, since you have determined the equivalent resistance parallel, you can replace these two elements by a single resistor whose value is 4.8. Okay. So, what we have done, since 12 ohms and 8 ohms are in parallel, okay, we have determined the equivalent resistance of these two. We want to reduce this resistance, we want to determine the equivalent resistance. So, we want to reduce the circuit. So, now to reduce the circuit, I am eliminating the parallel path here. 12 and 8 are in parallel. So, in order to eliminate this parallel path, simply determine the equivalent resistance of these two parallel branches, that is 12 into 8 by 12 plus 8, that is 4.8. Okay. So, now in this above circuit is modified as this circuit. Okay. So, here I have drawn a single resistor of 4.8 ohms. Now, you just observe here, current comes out of this current comes out of this positive terminal, and it flows through 5 ohms, and at this junction what is happening, current is dividing into two parts. Whatever current flows through 10 ohms, same current will flow through 4.8 ohms. So, current is not dividing here. Whatever current, I1 current flows through 10 ohms and I1 current also flows through 4.8. So, 10 and 4.8 are said to be connected in series. So, if elements are connected in series, if resistive elements are connected in series, you can simply add those resistances to reduce the circuit. So, here I have added 10 and 4.8, I have got 14.8. So, now my modified circuit is this. Okay, now instead of drawing two resistors 10 and 4.8, I have drawn only a single resistor of 14.8 ohms. Now, if you see, this is my positive terminal of the source, this is my negative terminal of the source. Current is coming out of this source, and at this junction what is happening? Current is dividing. Into two parts. So, here only two elements are there which are connected in parallel in this whole circuit. Therefore, in order to determine I1 current, okay, I can go for current division rule. So, according to current division rule, I1 current is given by the total current I into I1 current flows through 14.8 ohms. So, what is the opposite resistance to 14.8 ohms? 15. So, I into 15 divided by 15 plus opposite resistance plus self resistance. Okay. I1 current flows through 14.8. So, what is the opposite resistance to 14.8 is 15. So, total current is what? I1 equal to I into 15 by 15 plus 14.8. This is the formula. But we do not know I value. Let us determine I value. So, in order to determine I value, if we see 15 and 14.8 both are in parallel. So now let us eliminate this parallel path. What is the equivalent of these two? It is 15 into 14.8 by 15 plus 14.8. So 15 and 14.8 are in parallel. So equivalent is 15 into 14.8 by 15 plus 14.8. If you simplify, you will get 7.45 ohms. Okay. Now replace that 15 ohms resistor and 14.8 ohms resistor by this resistor, that is 7.5. Now this is our modified circuit. Okay. Now from this positive terminal of this source, current will come out of the positive terminal. It will flow through 5 ohms and same current will flow through 7.45 ohms. So 5 ohms and 7.45 ohms are said to be connected in series. So you can add those resistances. So they are connected in series. You can add them. So you will get 12.45 ohms. So this is it. This is my modified circuit. This is my total resistance in the given circuit. Now what is I value? I equal to V by R. I is equal to V by R equivalent. What is V? V is 4 divided by 12.45. 12.45. Just simplify it. You will get 0.32 amperes. So this is the current in the, this is the total current in the given circuit. Now I know I can determine I1. So I know I can determine I1 now. So what is the formula? I1 equal to I into this is I value 0.32 into what is I1 current is flowing to 14.8 ohms. So opposite resistance is 15. I into opposite resistance, that is 15 by opposite resistance plus self resistance. So I1 equal to what? 0.32 into 15 by 15 plus 14.8. Just simplify it, you will get I1 equal to 0.16 amperes. Now I know I1, I can determine I dash. So what is I dash? That is the current flowing through 8 ohms. This is what is asked in the question. So what is I dash? Enter total current entering this junction is how much? I1. So at this junction current entering is I1. So I dash equal to I1. This is I1 into I want to determine current in 8 ohms. What is the opposite resistance to this resistor? That is 12. So I dash equal to I1 into opposite resistance 12 divided by opposite resistance plus self resistance 8. So I dash is what? 0.16 into 12 by 12 plus 8. If you simplify, you will get 0.096 amperes. So this is the current flowing in the 8 ohms resistor when only 4 volts voltage source is acting in the given circuit. Now let us go to step 2. Let us assume only 6 volts voltage source is acting in the circuit. This is the voltage source which is acting in the circuit, and the 4 volts voltage source has been replaced by some short circuit. It has been replaced by short circuit. Okay. Now what is our aim? Our aim is to determine the current flow through 8 ohms. So let us assume current flowing through 8 ohms is I double dash. Now what is the current that is coming out of the positive terminal of this 6 volts voltage source? That is I. So this I current will flow through 12 ohms, and at this node what will happen to I? I will divide into 2 parts. I will divide into 2 parts. So there is a series parallel connection here of the resistors here. So we have to simplify this. First of all, we must determine I value. If we know I can determine I double dash by current division rule. So let us determine I. In order to determine I, what I will do is, I will just determine the equivalent resistance of the given circuit. I will determine the equivalent resistance of the given circuit. To determine equivalent resistance of the given circuit, what I will do is, this is our source, just go to the opposite side of the source and check. So see, from I current flows like this. At this junction what is happening? Current is dividing and this current will flow through 10 ohms. At this junction, what is happening? Again current will divide. Current has divided at this junction, that means 5 ohms and 15 ohms. 5 ohms and 15 ohms, they are parallel to each other. Okay, 5 ohms and 15 ohms are parallel to each other. So since 5 ohms and 15 ohms are parallel to each other, we can determine the equivalent of that. That is 5 into 15 by 5 plus 15, you will get 3.75 ohms. Now instead of drawing these two elements, draw only one single resistor whose value is 3.75 ohms. Now this is our modified circuit. Now see here, from positive terminal current will come out. Current will flow like this. It will flow through 12 ohms. At this junction, once again what is happening? Current will divide. But whatever current flows through 10 ohms, same current will flow through 3.75 because they both are connected in series. There is no current division here. Same current will flow because there is no junction or node here. So 10 ohms and 3.75 ohms are connected in series because same current is flowing. Okay, therefore the equivalent of those two resistors is 10 plus 3.75. So you will get 13.75. Okay, so you just redraw the given circuit and replace the 10 and 3.75 by 13.75 ohms. Now this is our modified circuit. Okay, now we can see I want to determine the current across 8 ohms resistor. Okay, parallel to 8 ohms resistor there is 13.75 ohms, only one resistor is there. Therefore now what we can do is we can implement current division rule here. So I double dash, what is I double dash here? I double dash is equal to total current. What is total current entering at this junction? How much current enters? I current enters. Okay, total current I into what is opposite to 8 ohms? 13.75. 13.75 divided by 13.75 plus what is the self resistance? 8. This is the formula to determine I double dash. Okay, do we know I? We don't know I. So what we have to do is, first of all let us determine I value. In order to determine I value, if you see current is flowing through 12 ohms and it is dividing into two parts. So that means these two resistors are in parallel. So you just eliminate this parallel path. So what we have to do is 13.75 and 8 ohms are in parallel. So you just eliminate it. 13.75 into 8 by 13.75 plus 8. So you just simplify it, you will get 5.06. So now redraw the circuit, you will get this. Now whatever current that is coming out of this positive terminal of this source will flow through 12 ohms and same current will flow through 5.06, means these two elements are connected in, current is not dividing, therefore these two elements are said to be connected in series. So you just determine the equivalent of those two, 12 plus 5.06. You have to simply add the resistance values if elements are connected in series. You will get 17.06. So 17.06 is the total resistance in the given circuit. It is the total resistance in the given circuit. So what is I value? I is equal to what? Total voltage, that is 6, divided by how much resistance? 17.06. So you just divide it and solve it, you will get I equal to 0.35 amperes. So now let us go back to the previous circuit and let us determine I double dash. So what is I double dash? Total current 0.35 into what is opposite resistance 13.75 by 13.75 plus 8. So this is our I double dash. You just simplify it, you will get 0.22 amperes. Okay, this is our current in the 8 ohms resistor when only 6 volts voltage source is present in the circuit. Now let us go to step 3. Let us assume all the sources are acting in the circuit, that is 6 volts and 4 volts. This is 6 volts, this is 4 volts. Both are acting in the given circuit. Both are there in the circuit. So here if you observe, there are 3 loops in the given circuit. So loop 1, loop 2 and loop 3. Okay, loop 1, loop 2 and loop 3. I have assumed loop currents. If you observe here, this loop current is in clockwise direction, this loop current is also in clockwise direction, this loop current is in anti-clockwise direction. Our wish, in whichever direction we want to assume the loop currents, we can assume. Here I have assumed I1 as the loop current, here I have assumed I2 as the loop current, here I have assumed I3 as the loop current. Now I am going to implement Kirchhoff's voltage law in loop 1. So according to KVL, algebraic sum of all the voltages in a closed path must be equal to 0, or algebraic sum of source voltages must be equal to the voltage drops in a closed path. So if you observe only this loop, there is one voltage source and 2 resistors in this loop. Okay, in this loop, loop 1, in loop 1, one voltage source and 2 resistors are there. So what is the voltage source value? 4 is equal to 5 into I1 plus 15 is between loop 1 and loop 2, and if you observe, the current direction this side is downward and current direction this side is upward. This is upward, okay, and this is downward. Therefore both are opposite. Therefore 15 into, since we are in loop 1, I1 minus I2, and if you simplify, you will get 4 equal to 20 I1 minus 15 I2. Okay, now let us apply KVL in loop 2. So if you apply KVL in loop 2, this is our loop 2. Okay, in loop 2, are there any voltage sources in this loop 2? There are no voltage sources. So source voltages are 0. Okay, equal to voltage drops in this loop. How many voltage drops will be there? 1, 2 and 3. Means voltage drop in the 10 ohms resistor, in 8 ohms resistor and 15 ohms resistor will be there. So let us start with voltage drop in 15 ohms resistor. We have already discussed the current direction. This is upward, this is downward. Therefore 15 into I2 minus I1, because we are in loop 2. Therefore I2 minus I1 plus 10 into I2, 10 into I2 plus 8 into, if you observe, this direction is downward, this direction is also downward. So both directions are same. Therefore 8 is between loop 2 and loop 3. Therefore 8 into I2 plus I3. Okay, now simplified, 0 equal to minus 15 I1 plus 33 I2 plus 8 I3. Okay, so now let us apply KVL in loop 3. So in loop 3, there is a voltage source of 6 volts and 2 resistors are there, 12 ohms and 8 ohms. Two resistors are there, 12 ohms and 8 ohms. So 6 is equal to, I have written 6 here, 6 is equal to, applying KVL, 6 is equal to 8 into I2, I3 current directions are same here, downwards. Therefore I3 plus I2 or I2 plus I3, you can write anything. Okay, 8 into I2 plus I3 plus 12 into I3 current. Okay, you will get 6 equal to 8 I2 plus 20 I3. Consider it as equation number 3. This is equation number not 2, it is equation number 3. So now solving equation 1, 2 and 3, you will get I1, I2 and I3. So I1 is 0.22 amperes, I2 is 0.032 amperes, I3 is 0.28 amperes. Okay. Now the value of current flowing through 8 ohms resistor. So what is the current flowing through 8 ohms resistor? It is I2 plus I3. What is I2 value? Just now we have seen I2 is 0.032 and I3 is 0.28. So 0.32 and 0.28, if you add, you will get I value equal to 0.31. Okay. So what is the current flowing through 8 ohms resistor when both sources 6 volts and 4 volts are connected? It is 0.31. Now let us verify superposition theorem in step 4. So when both sources were there, the current flowing through 8 ohms is 0.31. When only one voltage source was there, current flowing through is through 8 ohms resistor is 0.96. When only another source was there, the current flowing through 8 ohms resistor is 0.22. And if you add these two, if you see, they are approximately equal to each other, hence superposition theorem is verified. Okay. Let us discuss one more numerical problem. In the circuit shown in the figure, the internal resistances of batteries are 0.12 ohms and 0.08 ohms. Verify superposition theorem and calculate current in load 0.05 ohms. So 0.05, is it 0.05 or 0.5? So it is not 0.05, it is 0.5.